Hi, my name is Anashima Kwaza and I am a student at the Yusuf Community School here in Zimbabwe. Today I'm going to be presenting on my final project, which is on managing plastic pollution using automation. Plastic pollution has become a common problem in Zimbabwean societies. Many young people and organizations have been fighting tirelessly to solve the issue of plastic pollution. Other people which I would also like to mention are the people who are involved in small-scale plastic recycling. Organizations such as EMA have been sponsoring the cleanup campaign, which is held every month in the country. Although this is very beneficial to the country, there are quite a number of drawbacks which are associated with these kind of solutions. Take for example, the trends of events which are linked to a cleanup campaign can sometimes be tiresome. Processes such as waste collection, washing and sorting have to be carried out manually by the people. Another drawback which I would also like to mention, and this drawback is mainly linked to people in the small scale plastic recycling business. People who are recycling plastic in the small scale sector do not have protective equipment when they are doing their plastic recycling business. In my area, I have observed people moving around and around dump sites collecting plastic waste without wearing any protective clothing or equipment. People are being forced to get into contact with plastic waste without proper protection. This is very harmful to their health and can lead to very serious consequences. To avoid these problems, I designed a prototype of a smart plastic recycling machine. So I'm going to walk you through on how my prototype really functions. So this is a smart waste collecting container. This is a plastic sorter. This is the washing tank, a pump, and a supply tank. This is the crusher. So I'll be explaining what I just told you. So the smart waste collecting container. I wanted to create a scenario whereby suppose with the bottle waste, you don't have to keep on constantly checking up on the waste, but with the smart waste container, it depicts the level of the waste which is in the container. When the container is now full, I put a servo motor right down below, which would open so that the waste is released and collected from this point. As you can see, what is above here is an electromagnet. So as part of the aims of my project, I wanted to separate metals and plastics. So this is a small electromagnet. This is an ultrasonic sensor, which is the one which is responsible for measuring the distance between the waste and the sensor itself. Now we move on to the color sorter. The color sorter, its main purpose is to separate the plastics mainly based on their color. And one might tend to ask, why would we need to separate the plastics based on their color? I conducted a research, and from my research I realized that it would be much more cheaper if we were to recycle the plastics when they are already separated into different components of color. Let me give an example so that this makes sense. Suppose I want to make a red plastic, and the components which I'm using to make the red plastics, they are already red. This will be much more fast and cheaper because all I need to do is to melt these red things, and I may be able to stretch it and I get a red plastic. This will be different from a scenario whereby we have a bunch of plastics which are all of different colors and we get to blend them. They form a mixture of colors. And this is actually the cost whereby we have to buy dyes so that the color of the ultimate plastics can become red. So that was the main reason for putting this part of the project. It has a color sensor. This is the color sensor. And two servo motors, the one on the top and the one on the bottom. So the plastic sorter works in this way. I wanted to show you, like, you would put your different plastic containers through this hole as your prototype, and this top servo motor would move it from the inlet hole to the color sensor. From the color sensor will then depict RGB values. It doesn't give you like raw, it gives you like raw data, not like ultimate colors. Listen, this is red, this is blue. We have to calibrate it ourselves. So when it goes here, it then gives us raw values, RGB values, which we get to code in C programming and connect it to the Arduino Nano and tell it that this is red, so that this bottom servo motor will then lead the sorted plastic material into a different component. So this is the washing tank from which the sorted plastics are going to be dispersed into. So from this color sorter, we can see that there are different sections in the water tank. So when I was designing this project, I was putting red in this box, green in this box, and blue in this box. So we will be washing the plastics which have already been separated into different components. Compartments, sorry. Compartments. The water which you saw here in the tank is coming from this supply tank, which is also, I would like to say, determined is being smart. So whenever the water level is a bit low, the water is fed from this tank right into the washing tank through this pump. We had to make this pump using ourselves, using very locally available material. Last but not least, I would like to show you the crusher, which was like part of a model of what our aspiring machine would actually be like. So it's kind of standard as if it's independent. So after our plastic would have been washed or whatsoever, we are now putting it in a crusher so that it is split into smaller pieces. These smaller pieces to make it when the plastic is taken to maybe a melting plant, it will be much more easier for them to be melting the plastics. So I'm actually going to show you some of the things on the ground. For example, like the water level, we said that it has to indicate green, and this thing we have to be moving to and fro, trying to show you a simulation of how it separates the plastics. So I'm going to be connecting my power source, which is here, and I'll also connect another power source, which is here. So as you can see, it is indicating green, saying that the water which I put in this container is of right proportion. The tank is this optimum water level. If it were the case, we would show a different color, which I will show you also later. And as you can see, this plastic sorter is also moving to and fro as per section. Now it's on this section, now it's this section. Suppose I would have put an omelette here, it would then have to direct it into the respective compartment. So this is the crusher. The last part which I was saying is a bit independent. So just to simulate how the crusher will function, I connected this motor, and this thing has to propel now moving, and it will be splitting the plastics into smaller pieces. So this was like my whole project in brief. I also wanted to explain to you about the water level in the tank, and I'm going to be showing you. So as you can see, I moved this thing a bit much more further from the water surface, and it's now recording a greater distance from the water level. And this blue light indicates that there is now low water level in the tank. Suppose if I were to intercept here and enclose, bring much more very closer to the ultrasonic sensor, a red color now indicates that the water in the tank is now full. So I will close this thing. So as you were seeing, like it would help someone who is the owner of this thing to know that my tank is full, and automatically they will have to maybe supply the water tank itself. And using such a system would be efficient and much more smarter. I will be taking off the compartment and I will explain maybe how we calibrating the values for the different colors. So part of our project helped us to reflect maybe on how we can actually use a color sensor. So as for part of the pre-presentation, I had to remove the top cover for this thing so that you could actually see what was happening. But some of the difficulties which I faced while I was doing this project was mainly because this color sensor, I realized that it is very much sensitive to the light intensity which falls on it. So there were some times where we would have calibrated that red is like maybe an RGB value of maybe say our R is 54, G will be something like 20, or B will be something like 40, and it will be in the afternoon. But when it came to maybe like nighttime and we had to do the same, we're getting different values. So after I saw that, I decided maybe let's make it a what? A closed system. By making it a closed system, it means that our system now becomes independent of the external light sources, but now relies on the light from the sensor itself. So that was all about my project in brief, something which I really dream of creating maybe one day, a physical component. And during this project, I actually got to appreciate like how we can see physical, like programming working in the physical world. Because we had to code it on our C and upon the Arduino Nano, and we were seeing like this thing was generating motion out of like code. And I would really like to thank all my teachers who supported me, especially the robotics lab, for all the for all the components that they gave me. For example, the ultrasonic sensor, the buzzer, the camera sensor, the servo motors, etc. Working on this project helped me to work with the resources which are around me. I became a problem solver. All the stuff you're seeing here is basic stuff from my kitchen. So guys, this was all my project in brief. And thank you for listening. I'm out.